Assalamu alaikum students. Today's topic is going to be about numerical of chapter measurements. First question says, express the following quantities using prefixes, which are 5,000 grams, 2 million watts, 52 into 10 power minus 10 kilograms, and 225 into 10 power minus 8 seconds. So first of all, for 5,000 grams, first we'll convert this 1,000 into 10 power 3. So as we know that 10 to the power 3 can be represented as kilo, as 10 to the power 3 is known as kilo. So we can say 5 kilograms. So 5,000 grams can be represented as 5 kilograms. So this is the answer of the first part. Now for the second part, it says 2 million watts or 2 into 10 to the power 6 watts, or we can say 2 megawatts, because we know that 10 to the power 6 is equal to mega. Next, we have 52 into 10 to the power minus 10 kilograms, or we can say 5.2. We can carry out one digit from here or decimal point from one point to another. It will be 5.2 into 10 to the power 10, because one decimal point has been increased. So 10 to the power 1 into 10 to the power minus 10 into 10 to the power 3, which is kilo. So we can represent it as 5.2 into 10 to the power minus 9 into basically, which is 10 to the power minus 3, and we'll get minus 9, 10 to the power minus 9 into 10 to the power minus 3. It can be written as 10 to the power minus 6. So this is what we have done over here. So 5.2 into 10 to the power minus 6 grams. So what we will say to 10 to the power 6? We call it micro. So 10 to the power 6 is known as micro. So we can say simply 5.2 micrograms. This is the answer for the part C. Part D says 225 into 10 to the power minus 8 seconds. So we can put at the point 1 and 2. So it will be 10 to the power 2, and it becomes 2.25 into 10 to the power 2, and 10 to the power minus 8 will be as it is. So what do we do with the power of 10? It will be 10 to the power 2 minus 10 to the power 8. So answer will be 10 to the power minus 6. And as we know, 10 to the power minus 6 is known as micro. So we'll put micro over here. Let's see that how it becomes. So it will be 2.25 into 10 to the power 2. Now these two basically add up. It will be 10 to the power 6. What do we call 10 to the power minus 6? Micro. And that is why it is 2.25 microseconds. Problem number 2. How do the prefixes micro, nano, and pico relate to each other? First of all, as we know, that micro means 10 to the power minus 6, nano means 10 to the power minus 9, and pico means 10 to the power minus 12. Now, we can relate the micro with nano. As we know that 1 nano is equal to 10 to the power minus 9, we can say minus 3 and minus 6. We can breaking it down. So 10 to the power minus 9 can also be written as 10 to the power minus 3 into 10 to the power minus 6. So that you can go back and check it out. So it will be 10 to the power 3 micro, because 10 to the power minus 6 is micro. So 1 nanometer is equal to 10 to the power minus 3 micrometer. Similarly, the relation of micro with pico, it will be 1 picometer is equal to 10 to the power minus 12. So it is written as 10 to the power minus 6 into 10 to the power minus 6. So instead of writing down 2 times 10 to the power minus 6, we can say 1 time it is micro. So it can be written as 10 to the power minus 6 micro. And with the case of nano with pico, so what do we do? Pico is equal to 1 to the power 10 to the power minus 12. We break it into two parts, 10 to the power minus 3 and 10 to the power minus 9. As you know, 10 to the power minus 9 is what? Minus 9 is nano. So we put 10 to the power minus 3 nano. So 10 to the power minus 3 nano is equal to 1 pico. So this is the relationship between micro, nano, and pico with each other. Moving on to problem number 3, your hair grows at the rate of 1 millimeter per day. Find the growth rate in nanometer per second. So first of all, the given data which is given to us, the growth rate in 1 day is 1 millimeter per day. Required data is growth rate in nanometer per second. As we know that 1 milli means 10 to the power minus 3, and 1 nano means 10 to the power minus 9. So in 1 day, we have 24 hours, 60 minutes, and 60 seconds. If we add them or multiply them all, actually, we multiply them all, what do we get? We get 86,400 seconds. Now this is our answer in seconds instead of days. So 1 day contains this much seconds. Now for the conversion of nano, 1 millimeter per day is equal to 1 millimeter divided by 84,600 seconds. Actually, this is 84,600 seconds. So it is going to be 0.00001157 millimeter per second. And it is going to be 1.157 into 10 to the power minus 5 millimeter per second. Now, in this case, it is millimeter per second, but our answer was required in nanometer per second. So we have to convert the milli into nano. So 1.15 into 10 to the power minus 8, because milli means 10 to the power minus 3 and minus 5. That means 1.157 into 10 to the power minus 5 into 10 to the power minus 3, because it was millimeters. So when we add them both, it will be 1.157 into 10 to the power minus 8 meters. So it is written in 10 to the power minus 8 meters. So we have to convert that into nano. Now, if we have to convert that into nano, that means we have to move the decimal to 1 point. So here we go. So it is moved to the right hand side. So it is 11.57 nanometers. That means from here 1.157 into 10 to the power minus 8. The decimal is moved 1 digit to the right. It is 11.57 into 10 to the power 10. Or you could say 10 multiplied by 10 to the power minus 8. So this is 1 and this is 8. So 11.57 plus 1 minus 8. Or you can say in this case minus 1, because it's moving towards the right. So we are increasing the values, or in the power we are decreasing the value. So it is going to be written as 11.57 into 10 to the power minus 9 meters. So this 10 to the power minus 9 can be represented as nano. So that is why we have written 11.57 nanometer. Now, next question, it says, rewrite the following in the standard form. So this is basically 1168 into 10 to the power minus 27, 32 into 10 to the power minus, plus 5, 725 into 10 to the power minus 5, and 0.02 into 10 to the power minus 8. We have to convert that into standard form. First of all, question part A, 1168 into 10 to the power minus 27 can be represented as 1, 2, and 3 decimal to the point over here. So it is 1.168 into 10 to the power minus 27 plus 3. That means 3 decimal points has been moved. So now minus 27 plus 3 will be written as 1.168 into 10 to the power minus 24. And that is your answer. Next question, 32 into 10 to the power 5. So decimal was over here. It moved from here to here. So it becomes 3.2 into 10 to the power 5. So it moved 1 decimal. So it is 10 to the power 5 plus 1. It will be 3.2 into 10 to the power 6. So 5 plus 1 is 6. Third part or C part, which is 725 into 10 to the power minus 5. So how many decimal points have we moved? 1, 2. So over here, so point will be over here. If the point is over here, that means it is 10 to the power 2. So it becomes 7.25 into 10 to the power minus 5 plus 2. So 10 to the power minus 5 plus 2, it will be minus 3. So our answer is 7.25 into 10 to the power minus 3. The last part, which is the D part, in this case, we are going to say, which is 0.02 into 10 to the power minus 8. It can be written as like this. So it is 0.02 into 10 to the power minus 8. So 1 and 2, actually, not in this case. We have to make it scientific now. Now we have to move towards the right. So 1 and 2 towards the right. So it is in basically negative. So it is 10 to the power minus 8. Now it moves 1 and 2 decimal towards the right. So it is negative. So it is minus 2, 10 to the power minus 8 and minus 2. So when we add them both, because both of them are in negative, so answer will be 10 to the power minus 10. So 2.0 you can say into 10 to the power 10 or minus 10 in this case. So this is our answer for this question. Question number 5 says, write the following quantities in the standard form. Now we have to write all of these quantities in the standard form. So the first one is 6,400 kilometers. So 6,400 kilometer can be represented as 1, 2, and 3. So the decimal point, I moved 3 points, so 6.4 in 10 power 3 kilometers. So this is the scientific way of writing it down. Now next one is 3,080,000 kilometer, and it can be represented very simply as 3.8 in 10 power 5, because 1, 2, 3, 4, and 5 decimal are moved. So 3.8 in 10 power 5 kilometer. This is also written in scientific form because one digit is before the number, which is non-zero, and one digit come after this one. So this is the scientific way of writing down, or you can say the standard form of writing down the values. Question number C, it says 300 million meters per second, or you can say 3 into 10 to the power 8, because 1, 2, 3, 4, 5, 6, 7, 8 decimal were moved towards the left. That is why we are writing down 8, 3 into 10 to the power 8 meter per second. Very simply, this is the speed of light actually. Next, seconds in a day. So we know that there are 24 hours in a day, and there are 60 minutes in an hour, and there are 60 seconds in a minute. So if we multiply them all, it will be 86,400 seconds. So if we want to write it down in the form of scientific form, so 1, 2, 3, 4. So 8.64 into 10 to the power 4 second is the answer for this question. Then question 6 says, on closing the jaws of a vernier caliper, the zero of the vernier scale is on the right. To maintain such that fourth division of the vernier scale coincide with one of the main scale, find the zero error and the zero correction. Now, here's the situation. First of all, for simplicity, let me draw the vernier caliper, a rough diagram. So as you can see over here, there's a vernier caliper over here. So it has basically two scales. One is the main scale, which is on top, and one is the vernier scale, which is on the bottom. We are focusing on this point right now. So for clarity, I'm writing down like this. So this is 0, and this is 1, 2, 3, 4, 5. And on the bottom part, it says over here, the 0 on the vernier scale is on the right. That means the 0 on the vernier scale is over here onto the right side of the main scale. And it says to its main scale and the fourth division of the vernier scale. That means this scale which you are talking about, its fourth division, 1, 2, 3, and fourth division is coinciding with the main scale. That means this was the main scale, and this was the vernier scale. So the fourth division was basically coinciding, was coming in line, in the same line as that of the main scale. Now, what is the zero error in this case, and what will be the its correction? Now, what is the error in this case, and what will be its correction? That is the question which is being asked. Now, that is very simple. First of all, we have to calculate the least count of this one. Least count. Now, what is the value or the formula for least count? Very simple. The least count says the smallest deviation on main scale divided by total deviation on the vernier scale. So let us write it down clearly. So the vernier division is coinciding, which is fourth division. We have the least count, which is 0.1, because we know the main scale value is 0.1 centimeter, and the total deviation on the vernier scale, which we got basically was 10 deviations. So if we divide it, it is going to be written as 0.01 centimeter. So this is the least count of the vernier caliper, which has a formula. Let me write it down again. The least count formula: smallest deviation on the main scale divided by total number of deviations on vernier scale. Now, this is the concept. Now, what do you mean by the smallest deviation? That means if they are in centimeters, then the smallest deviation on the main scale is 0.1 centimeter. And how many deviations are there on a Vernier scale? We can say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are the deviations total on the Vernier scale. We can say VS. And for this, we can say MS. Now, if we put the values in this formula, which is of the least count, we found out the smallest deviation is 0.1 centimeter, whereas the total number of deviation on the Vernier scale is 10. So if we divide 0.1 by 10, we get the least count of 0.01 centimeter. So this is what I have written over here. It is 0.01 centimeter. Moving on to the zero error. So error was how much? 4 deviations. So we multiply this least count with this deviation, it will be 4 multiplied by 0.01 centimeter. So error is this much, but it was positive or negative. Either it was right hand on the right or side of the Vernier caliper or left side. So it says the error is positive. That means something was included into this one. Extra things was included. So that is the positive error. That means the jaws of the Vernier caliper were not closed properly. That means some extra readings were included into it. How much extra? 0.04 centimeter. And what is the correction for this one? The more we add, basically, the less we have to subtract. That means the same amount we have to subtract. So the zero correction will be the same amount, but in negative. So that much we have to neglect to get the accurate value in the case of Vernier caliper, which is the answer minus 0.04 centimeter. The next question says a screw gauge has a 50 deviations. On a circular scale, the pitch of the screw is 0.05. What is least count? Again, so this is a screw gauge. Let me draw a rough diagram over here. So this is a screw gauge. This is a circular part, and this has a linear scale over here, and the circular scale basically has movement over here. So here we have something to put into. This is what you call a spindle, and this is known as anvil. That means it doesn't move, and this will be screwed so that it can close its jaws right over here. Now, in this case, the reading on the main scale, basically, or you can say main scale, you can say in certain cases, or you can say the linear scale. So in this case, we have the readings on the linear scale is basically given to us. The smallest deviation which you can find on this one is 0.5 millimeters. So it is 0.5 millimeters in this case. And we don't have readings on this one, but we have deviations. So how many deviations are given to us in this question? 50. So it is 50 deviations given on the circular scale. So this is circular. Let me write down it clearly. So over here, it is circular scale. And this one is the main scale, or you can say the linear scale. Now we have the circular scale reading, we have the main scale reading as well, which is 0.5. What is the formula for least count? Okay, least count, LC, is basically, again, the pitch of the screw, or you can say pitch of screw divided by total deviations on circular scale. Now, in this case, if we say that it is the smallest deviation on linear scale, it is also correct. Smallest deviation on main, or you can say linear scale, the same thing. It's the same thing. So the pitch of the screw, which is given to us in the question, it is 0.5. It is 0.5 divided by how many deviations on the Vernier scale? It is 50. So 0.5 divided by 50. Whatever the answer comes, it is going to be the least count. So this is the formula for least count, which we are going to find over here. So let us calculate. So number of deviation on the circular scale is 50. The pitch of the screw is 0.5 millimeters. So the least count of screw pitch can be found out by the formula below. It is the least count is equal to pitch, the pitch of the screw divided by the total number of deviation on the circular scale. So it is 0.05 millimeters divided by 50. So answer is 0.01 millimeter or 0.001 centimeters. Thus, the least count of the screw gauge is 0.01 millimeter or 0.001 centimeter. And we can convert millimeter into centimeter just by dividing by 100, or sorry, by 10, because 1 centimeter contains 10 millimeters. So 1 millimeter will contain 1/10 centimeter. So that is why if we divide this whole value by 10, our answer will be in centimeters. So that is why I've written down both the cases so that you can convert this one. Moving on to the next question, it says which of the following quantities have 3 significant figures? Let us choose. So over here it is 3.0066. B option is 0.00309. Then we have 5.05 into 10 to the power minus 27. It is minus 27 actually, written like this. Let me write down it clearly so that you can understand this one. Yeah, so instead of writing like this, you can say minus 27 over here. Kilograms, and the last one is 301.0. So the first one, A part, is 3.0066 meters. So we can say the significant figures in this quantity is 5 because their 0 is in between these two significant figures, which is 3 and 6. So 1, 2, 3, 4, and 5 significant figures are given over here. So this is not the answer which we are looking for. We are looking for 3 significant figures in the given data, because the zeros between the significant figures are also significant. These zeros are also significant. So that is not our answer. Moving on to the next one, it is 0.00309. So we are not considering these basically 3 zeros because they are on the left hand side of the significant figures, but this 0 we consider according to the rules of significant figures, that 0 which is in between the two numbers is also significant. So here we give the reason. The significant figures in this quantity are 3. So 1, 2, and 3 are significant over here. So this one is significant. The option is significant of 3 figures because the zeros used for spacing the decimal are not significant, but the 0 which is in between the two significant figures is significant. The C option says 5.05 meters per minus 27 kilograms. So here we have figure has 3 significant figures, which is 505. So over here we can say because the 0 between the significant figures is also significant. Now 3010 over here, the significant figures in this quantity are 4 because 1, 2, 3, 4 and 0 is after. So that is also significant because on the right hand side, so it is significant in this case because the 0 after the decimal is also significant. So in this case, option C is significant. Option B was significant, and that's it. There are 2 significant figures in this whole scenario. Moving on to our conclusion that option B and C have the 3 numbers of significant figures in this case. Moving on to the next question, numerical number 9, it says, what are the significant figures in the following measurement, that means 1.009 meters and 0.00450 kilograms and 1.66 into 10 to the power minus 27 kilograms and 2001 seconds. So for the first one, how many significant figures are there? The significant figures in this quantity are 4 because the zeros are in between the 2 significant figures which are non-zero. That means 1 and 9. As you can see over here, 1 and 9 and the zeros are in between. So there are 4, 1, 2, 3, 4 significant figures. Because the 0 between the significant figures are also significant. This is the reason for this one. Next one, it says 0.00450. So these are not significant because they are on the left hand side of the significant figures. So what do we have? The significant figures in this quantity are 3. So 4, 5, and 0 are significant, and the other 3 zeros are not significant. And we can give the reason because the 0 used for the spacing of the decimal points are not significant in this case. 1.66 into 10 to the power minus 27 kilograms. The significant figures in this case are 3. So 1, 2, and 3. So because all the digits before the power of 10 are significant, that means all of these are non-zeros and are before the power of 10. So that They all are significant figures. So 1, 2, 3 are the significant figures in this one. And 2001, so in this case, the significant figures are 4, every 1, 2, 3, 4. And as the zeros are in between the two significant figures, so these zeros are also significant. So that is why we are saying, because the zeros are between the significant figures, they are also significant. Question number 10 says the chocolate wrapper is 6.7 centimeter long and 5.4 centimeter wide. That means length is 6.7 centimeter and width is basically 5.4 centimeter. We have to find the area in this case. How much is it? According to its significant figures. So significant figure in both the cases, in the case of width as well as in the case of length, both of them are two significant figures, 1 and 2. Even if we have different significant, like it was if 5, then we have chosen 5 for the significance. We have to choose the least value for the significance of a number. So solution in this case is going to be the length, which is 6.7 centimeter. The width is 5.4 centimeter. The area we have to find out. Now we can say length into width, which is the formula for rectangle. To find the area for rectangle, length into width. So let us multiply these two values. So it is 6.7 into 5.4. So our answer comes out to be 36.18 centimeter square. So it is 4 significant figures over here. But in the given data, we have only 2. As you can see, 1, 2, 1, 2. So our answer must also be in significant figures. So we round it off to 36 centimeters square. So only 2 significant figures are used over here, which is 3 and 6. I hope you enjoyed today's lesson. Inshallah, we'll continue again. Bye.